So I thought it'd be interesting. So you saw part of the UI. I think you've seen other parts of the UI previous field days. In the data science group, that's kind of actually a small part of what we do. So I thought it'd be interesting to talk through some of the things that Rod had alluded to earlier. Specifically, so we have this huge data warehouse. It's a lot of work to maintain, but the benefits are there as well. So I want to talk a little bit about that. We'll do 2 case studies, one related to VMware and another one that came up fairly recently, and summarize. All right, so I think I've been doing data science work for about 18 years in a lot of very different industries, and the same problems come up every day.
That's about 12 years more than they've been calling it data science, right?
I've been so happy when they got the term. Before that, it might have been operations research, it might have been statistics, it might have been machine learning. Yes, so I was extremely delighted. But it's even a bit worse now because we have more systems talking to each other, a lot more volume. Rod mentioned the sort of volume we get from sensors coming in from our own arrays. If we have a big enough VMware environment, the VMware stats alone can be over 500, 600 million different sensor values a day. So all that stuff didn't come in. To the extent also that we're dealing, especially with third-party systems. If all of a sudden, instead of seeing a number we expect to be, say, throughput or latency values, we see an error code, or we see something like a -1 or something like that, if we're not ready for that and we haven't designed the code, the algorithms for that, that can really play havoc on the kind of latency analysis that you saw with the VM Vision. And again, this is not a Nimble thing, it's just anyone who's dealing with enough data has this problem. So we spend a lot of time, making sure our data warehouse is solid. And one of the things that we've done right from day one is getting all of that information into it, having it always available in the database, keep checking if things go wrong, so that when issues come up like the ones I'll talk about, we can react to those quickly and investigate. So for example, one of the kind of weird things we do, it's kind of funny, is I say teach your systems what a number looks like. So if I have a stream of data coming in from a particular API, we actually monitor what that data tends to look like. Maybe it's 0 part of the time. When it's not 0, it's positive within some range. So that something shifts, if something gets mixed up, we can actually flag that before it becomes an issue. And again, fundamentals, if this is a more technical talk, I could go into statistics and numerical analysis and all the fun stuff, but you saw some of the other slides about how we do differential equation modeling, things like that. Again, we spend a lot of time focusing on the algorithms and making sure they're stable and robust. All right, so this one I thought, one of the things that was interesting about this is the first time so when we were preparing for VM Vision, first we had to get all the data in place and get the database built up. This was the first time we got to actually use that information to handle the customer issue. And that issue was the VMware environment, very big latency spikes, people getting kicked out of sessions, and kind of a lot of confusion as to what the cause was. And now back to statistics, one of the interesting situations was that when you had those spikes, all of a sudden you started seeing more gaps in the information coming out of VMware. So what we had done already as part of our data preparation was we had logic in place to kind of fill in stuff that's missing as much as possible. So if I see operation counts from VMware that are missing, we have our own operation counts and volumes that we can use to heal in. Maybe we also have throughput that's there, so we can kind of fill in the gaps as needed. And we were able to describe, what VMs were involved. It was large sequential writes. And we were able to pinpoint a couple of patterns. One was, you would see maybe 10, 20, 30 VMs all go off at, fairly close together in time, but it wasn't the same ones every time. It wasn't like a regular job happening. And even though they were close to the same time, they weren't exactly at the same time. It looked random, but it actually looked a little too random if you do the analysis. So that and the fact that activity was concentrated on what I call the OS, the sort of 0/0 unit number of VMDKs, gave enough clues for one of our engineers to kind of pinpoint the problem. Any guesses? Antivirus updates. So what was happening was, the antivirus software in the environment was set to update a whole bunch of VMs with sort of a random time within 5 minutes of each other. Okay, so once they changed that setting, so it was random over 12 hours instead of 5 minutes, all the problems went away. So because we had done so much, groundwork, for our data warehouse, we were able to very quickly, okay, let's look at it this way, let's look at it by VMDK, let's go back a couple weeks, look for similar times that's happened in the past, and get to an answer fairly quickly. So being able to look at the patterns, we've already dealt with the missing information, and being able to describe the randomness that was present, made solving the problem fairly easy.
And what triggered this was you were seeing some write performance problems, or write performance?
Overall latency problems. So the customer was complaining about, again, just every now and then.
Customer was complaining about performance issues. Yeah.
Exactly. Yeah. Along the same lines. So a while back, again, there were a small set of faulty drives with a different kind of failure that we had seen before. Involved media errors. You see media errors first. And gosh, my mouth is really dry. 1 second. You got water? Yeah, I got one over there. I forgot to bring with me. Thanks. Before my lips stick together while I'm trying to talk. So something brand new, but again, affecting performance for the customer's array. So the analysis here wasn't as interesting to me as the last one, but what was interesting about it was the way we went about solving it. So we had one customer that we knew of that was affected, and we needed to do something as quickly as possible for them so they could know that, okay, if I replace this drive, then things will be okay again. But again, we also needed to know if there were any other customers out there that could be hitting this at the same time, because at the time we didn't know how prevalent it was. And in doing so, again, we worked with engineering to develop, find out what was going on, develop a model to detect it, so that longer term, that could be integrated into Nimble OS, which can fail the drive automatically when it saw the conditions. So again, we worked in engineering to develop a model and be able to detect when a drive kind of separated from the pack, one or more wise, and stayed there for enough time. And I remember this very clearly because this problem came in on Friday, and we had to have something, going before the weekend. So we were very quickly able to implement sort of an automated check for the customer at risk that ran every 2 hours. It could have been made much tighter, but the temporal aspect of the problem was such that a disk drive needed to be in that state for about 3 hours for it to be an issue. So that's why we picked 2 hours. And we also were able to then go extend that search across the entire install base and find out what customers also had drives that could cause the same problem and get those fixed get those replaced before it caused any issues.
This is not a question for you, but I guess the question, do you guys do like system burn-in and stuff like that? Where, before you ship something to a customer, you run it for a certain amount of time in-house?
We do that, and we do that on drives as well.
You do that and do that on drives? What's the length of time?
I believe it's about 48 hours.
48 hours on the drives and the system?
Yeah, system level, the drives.
So this occurred out in the field after that burn-in period?
Yeah, and it wasn't like it was out of the, what wasn't a, what I would say a DOA. They got into that state over time. The other thing I'll point out that just to clarify something that Mark was alluding to there. So he said that we were collecting and monitoring this one particular customer system every 2 hours, that we could have actually shortened that if we needed. So we actually do have the ability to remotely ask an array to send us any stats we need at whatever granularity, either per second or per minute, at whatever frequency we want to get that at. So as an example, if we really wanted to, we could have it send per second stats every 2 minutes, for example. This one didn't require that level of granularity, as Mark said, just because of the nature of the temporal factors that went into this. But we can easily do that for any array when we need to.
Yeah, that's a good question. I don't remember how long the array had that drive, but it was quite a while. It wasn't anyway a new thing. There were some questions earlier about the data for VM Vision. It again kind of piggybacks on the same delivery process, although they were limited to the granularity that the VMware APIs can provide. So, with both these cases, the first one and this one too, the commonality there is that something happened that people really hadn't seen before, resulting in reduced performance. We're able to, again, use this carefully curated data warehouse to help diagnose a problem, interacting with engineering and customers, et cetera. And then, get a pattern that we can then go, look for in the future if it comes up again, or, look for in the past or in the present, go extrapolate it to, or basically, scan through all the active customers and see if anyone else is having the same issue. So again, I mentioned doing this a long time. So in terms of having good information available to analyze, to use to predict the things, I've become convinced it's very much a cultural issue. It takes a lot of pain, a lot of effort, a lot of focus to make sure all the numbers that you're relying on are good. Or if they're bad, you know how they're bad and you've accounted for that in the analysis and the algorithms. It's always possible that something new happens. If we have an array, say in a VMware environment, on a new customer, something in that customer's environment could all of a sudden produce something weird that we see in the VM data coming back. We've even seen cases where, for a particular drive model and firmware type, some of the smart data was kind of weird, right? So nothing's ever totally secure against new issues coming into the analysis. But we can deal with those comprehensively and robustly. And our ability to, again, respond quickly, to be able to do this kind of analysis within a day or less once a problem arises is a function of that. And then finally, like I mentioned, we find problems, we can sort of store that signature, add that into the code, add it into health check code if we needed, and deal with that.
Last year, you guys mentioned how many systems do upgrades during business hours.
Yes.
Has that changed at all, or what have you gathered from that sort of data
Waiting for
from under the hood?
I thought I'd be sooner too. Were you going to mention that, Tomasz?
Yeah, and I actually did the study just the other day, anticipating such a question. So on the latest software stream that we have in the field is 2.3. That's our latest release. That one was exactly the same number, believe it or not, at 61%. Still updating during prime time, 9 to 5, Monday to Friday updates in their local time zone. That's correct.
So I never bring a laptop to something like this, and one of the reasons is we have such a rich data warehouse that I think someone asked the question about how long does it take for people to upgrade to a new OS version. My immediate reaction is to get into the database and start hurriedly typing to figure that out. So.